Today we are going to revisit exponential growth and decay. So here I have some formulas for you at the top of these notes. The first two boxes are not new. We have growth and decay standard, and we have continuous. And the last one is, I could call it new, I guess. But you've seen it before. It's the compound interest formula. Well, hopefully you've seen it before. You should have seen it in Algebra 2, compound interest. And that's actually new to the IB curriculum. Compound interest wasn't a thing in this level of mathematics before the new curriculum. So I'm going to be honest with you, I don't know if it's going to be on your IB exam or not. Is it okay if I sit in the back? We'll just have to see, okay? But what we're going to do now, when I stepped on a laptop, what we're going to do now that's different from before is we're going to use logarithms to solve for things that we weren't able to solve for beforehand. Before, when we were solving our exponential, whoa, I just threw my pen at the computer. Before, when we were solving the exponential equations, what we were doing on our graphing calculator was we were setting the equations equal to a horizontal line, and we were looking for intersections, right? Well, now we're gonna go back and revisit those questions, but we're going to solve those using logarithms. So that Unit 3 test that we took when we were having trouble leaning on our calculators, could you have used logarithms? Yes. So from now on, if you're dealing with something exponential and it's calculator active, you can either solve using logarithms if you would like to do it that way, or you could lean on the technology. Let's see. A farmer monitoring an insect plague notices that the affected area by the insects is given by that formula over there, 1,000 times 2 to the 0.7 in hectares, where n is the number of weeks after the initial observation. We want to know how long it will take for the affected area to reach 5,000. Now, we could graph this on a graphing calculator. We could graph 1,000 times 2 to the 0.7 n as line 1, and y equals 5,000 is line 2, and do the whole second trace intersect thing. Or we will flex our logarithm muscles and solve the equation algebraically. Let's go ahead and do that. 1,000 times 2 to the 0.7 n equals 5,000. Wow, this board is lagging badly. My computer's struggling. It writes slower. There we go. So we're going to solve using logarithms, okay? First things first, you're going to divide both sides by 1,000. You got to get that 1,000 to go away. Divide both sides by 1,000. And you're going to be left with 2 to the 0.7 n equals 5. All right, well, normally what we would do at this point is we would cancel exponential base 2 by using a log base 2, right? But what that means is on the right side, you're going to have a log base 2 of 5. And there's nothing wrong with that, except for the fact that you might not remember how to type log base 2 of 5 on your calculator. You might not remember that you're even supposed to use change of base for that. So instead, which you could do, and if you're comfortable with those things, go for it. Instead, what I'm going to do is I'm just going to take the common log of both sides. Just going to take the common log of both sides, which is actually why change of base works. But if we just take the common log of both sides, log of left, and just write it right over there, log of right, what we can do is take this exponent out of the exponent position and move it to the front of the logarithm. So what you would get is 0.7 n times log of 2 equals log of 5. So if you wanted to isolate n, you would just divide both sides by whatever is sitting over there with n. You see these are all multiplications over here. So I can divide both sides by 0.7 log of 2. Those are both numbers. So what it is, I sidestepped change of base. My result is what I would have gotten had I used change of base. And let's see, so this is log 5 divided by 0.7 log 2. Let's see what we get. Let me grab my calculator, because I don't know the numbers. of 5 divided by 0.7 log 2. And I got 0.3. Oh, that's because I goofed up and forgot to use a set of parentheses. What's that? I know. There we go, 3.32. That sounds better. 3.32 weeks. See, what happened was I didn't use a stacked fraction on my calculator. I just did log 5 divided by 0.7 log 2. And what the calculator did was, because it was trying to follow the order of operations, it did log 5 divided by 0.7, and then it multiplied by log 2. So what I had to do was I had to wrap my entire denominator in parentheses in order to get the correct answer. I'll just go ahead and write. If you type it like this, it'll give you a wrong answer. So this doesn't work. Because the calculator sees this as a multiplication, so it's trying to follow the order of operations. It does the division, and then it does the multiplication, which put that log 2 on the top of the fraction instead of the bottom. So what you have to do in order to get it right, if you're not going to use the stacked fraction, is you have to tell the calculator, no, that whole thing is my denominator.
What if we type division twice?
Or you can just hit division twice. That works too. There. That's how you get the right answer. Yeah.
You can put the 0.7 as just put it back as like the exponent of 2 cents. Do that.
So on the bottom, do divide by log of 2 to the 0.7. You could do, yeah, you could do that also. You could do that also. Either way, we get 3.32 weeks. Yay, algebra. Logarithms are not magic, they are algebra. Irina has $5,000 to invest in an account that pays 5.2% per annum interest compounded annually. That just means simple interest. Okay, PA means per annum, it's just simple interest. So this is the not PERT formula because it is not compounding continuously. This is going to be 1 plus R. So we will be using the amount is principal times 1 plus R raised to the T. We'll be using that formula for exponential growth. It says, how long will it take for her investment to reach $20,000? All right. Well, we just have to fill things out. We know it's going to be $20,000 on the left side equals our initial investment of $5,000. In here, I'm going to do 1 plus, and I am not going to do 5.2. That's not going to work that way. You can't use the percent, you must use the decimal format. So our rate is 0.052 raised to an unknown time. So if you divide both sides by 5,000, you get 4. That's easy maths. 4 equals 1.052 raised to the T. I keep stepping on this laptop. I need to move it before I break it permanently. There we go. Okay. There. I mean, we just got to get T by itself now. Yes? So compounded annually means 1 compound per year, but the compound interest formula compounds several times per year, n times per year. So if we use this formula, n equals 1. So you still get 1 plus r raised to the t because both of the n's equal 1. So it is actually the same formula. So this one is what you get when n equals 1 time per year. So if I said compounded monthly, you'd have to use the last one and n would equal 12, right? We need to get t by itself. Well, we could just do log base 1.052 to both sides. And then our answer would be t equals log base 1.052 of 4. But if you don't remember how to get the log base operation from your calculator, you're going to struggle. You'll have to remember change of base formula. So again, what I'll do is I'll just take the common log of both sides because that'll allow me to just drop the t down to the front. Come on, active Bantam, catch up with me, please. Please, please, please. Let's do this. Painful. Okay. Log of 4 equals log of 1.052 to the t. And of course, you could put that t in front because it's an exponent. And then lastly, divide both sides by log of 1.052, which is what change of base would have given you anyway. Log 4 divide by log 1.052. Again, I don't know what that is, so I'll grab my calculator. I got 27.3 years. It's a long time. But you know what? That's remarkably fast compared to what it would take now. Because 5.2% interest, jokes. Current interest rates are like 0.25%. Yeah, they're bad. Interest rates are near zero right now. And they'll be like that for the rest of your life. Unless something catastrophic happens. Let's hope for not catastrophic. We good to move? That won't change the interest rates, though.
Yeah, but if people start losing jobs and the economy starts crashing, it definitely will.
Hey, look! It's the thing I just said to Erica. Irina has $5,000 to invest in an account that pays 5.2% per annum interest compounded monthly. For how long? Find how long it will take for her investment to reach $20,000. So it's the same question, only now we have to use the compound interest formula. Now, because we're compounding more than once per year, we would expect this to reach that $20,000 faster than 27.3 years. How much faster? Honestly, I don't know. Let's find out. But I will use this formula. To be honest with you, I don't know if it's in the reference sheet, so it's something that you need to know. I'm just going to go ahead and tell you right now, if you don't have the formula memorized, you need to memorize that one, because I don't think it's in the reference sheet. I could be wrong. Just memorize it. So 20,000 equals 5,000. 1 plus, again, don't use 5.2, 0.052. It says per month, or monthly, excuse me, so we have 12 months per year, raised to the 12t. I don't know what 0.052 divided by 12 is, so calculator will be our friend here. I will, oops, missed a 0. Let's squeeze it in there. Divide both sides by 5,000. Again, you will get 4 equals. And let's see what's inside those parentheses. 1 plus 0.052 divided by 12. Holy goodness, that is a repeating decimal. So how do we want to write this to make sure that we get an exact answer? Yeah, we might be best served leaving this as a fraction. Because to 3 sig figs, that number's a 1, which is a problem. Because that would make your answer 4. So something's really not working there. We can't use 3 sig figs. So yeah, I think we're just going to have to leave this as a fraction. So let's say 1 is 12 over 12. So this is 12.052 divided by 12. Raised to the 12t. All right. We okay so far? Same trick. Log of both sides, which will drop the 12t down to the front. If combining those steps gives you a headache, let me know, and I will make sure that I show that step happening. But I'm combining the steps of logging both sides and moving the exponent to the front of the logarithm. There. So we can isolate t right now by dividing both sides by 12 times the log of that nasty fraction. And that gets t all alone. I'll actually write that. So dividing both sides by 12 log of 12.052 divided by 12. Yikes. That is scary. Oh, I gotta write it over here too. I'm gonna be honest. I'm gonna use stack fraction operation on the calculator because I have a fraction inside of a fraction inside like a fraction inside a logarithm inside a fraction. Oh man, that's just frightening. Let's see, t equals.
Wait,
Yeah, what's up?
you multiply the top and bottom by 12, but
No. I didn't multiply the top and bottom by 12.
wait,
What I did was when I took the log of both sides, this was an exponent that I scooted to the front of the logarithm.
my bad.
No, it's fine. That's why I said I was not writing that step, and I probably should have.
It was just because when I read that, I was like, wait,
Mhm.
0.52 shouldn't be 0.52.
So 12 log of 12.052 over 12. Now, normally I would fire up the graphing calculator program and have this on the video, but you can see just having the broadcaster open along with Zoom and ActiveInspire is crushing this computer's brain power. So I am going to use the graphing calculator in my hand and do math, frac, n over d. So up top, I'm going to type log 4. And on the bottom, I'm going to do 12, and then math, frac, n over d again. Yay. Oh, it didn't do it. Clear. Oh, when I hit clear, it cleared everything. I shouldn't have done that. I can start over again.
When you did that, though, it sounded like defibrillator.
12 times math, frac, n over d. There we go. Log of 12.052 divided by. What an ugly thing to type. Okay, moment of truth. I should get a number smaller than 27.3. 26.7. So it took 0.6 years less. So it's like what, 7 months faster, something like that? Compounding monthly instead of yearly. You ever notice how whenever you're in math class and we teach you about compound interest, we always teach you the PERT formula for continuous compounding, and then we make you do questions using it? No banks use PERT. No banks use continuously compounding interest because it's the fastest growing interest there is. They don't want you to have more money. Because there are things in the real world that use it. Radioactive decay and what are growth rates of like crystals and things like that.
I thought radioactive decay was just like half, like, I thought the radioactive decay was a different formula.
No, radioactive decay, you're thinking of half-life. The half-life formula has an E in it, but it is exponential. It is continuous. Oh, you know, another thing we use exponential growth and decay for is heating of things and cooling. Newton's law of cooling, which is the same as Newton's law of heating, basically.
Wait, nuclear decay, radioactive decay, and half-life are different?
No, they have a different formula, but their half-life is based off of continuous decay. It's based off it, but we use half-life because we want to know specifically how long until it's halfway gone. So it changes the exponent a little bit. But that was it for today's notes. So we've seen now how to do these things using our calculators to look for intersections. And we've also seen how to solve by hand. Remember, you're not always going to be rewarded for showing extra algebra work on an IB test.